A streak of superheated metal tears across the sky at Mach 6.5. No smoke, no explosion, just electromagnetic fury. That's Japan's new railgun, fired from a warship deck. Across the South China Sea, a Chinese laser turret tracks the horizon with silent precision. An invisible beam designed to burn drones and blind missiles. Two nations, two futures. One fires steel faster than sound. The other fires light faster than thought. They're aimed at the same ocean. Which one will survive real combat? Railguns promise unstoppable kinetic destruction. Lasers promise endless precision defense. Which one will decide Asia's balance of power? To answer, we go back, not to Tokyo or Beijing, but to where the railgun story began, the United States. In the early 2000s, the U.S. Navy poured hundreds of millions into an electromagnetic cannon. No warheads, only a metal slug accelerated at nearly Mach 7. One shot carried the equivalent force of 200,000 rifle rounds. Range stretched over 100 miles. Cost per shot roughly $25,000. A fraction of a cruise missile. On paper, it was revolutionary. In practice, physics intervened. Each shot demanded 25 megawatts of power, roughly the output of a destroyer. Barrels wore out fast. After a few dozen to 100 shots, accuracy and reliability collapsed. The program bled money, and in 2021, the Pentagon quietly shelved it. What looked like the future became a budget casualty, a YouTube-era spectacle rather than operational warfare. Japan refused to let the idea die. A TLA, Japan's Acquisition, Technology and Logistics Agency, salvaged U.S. designs, re-engineered weak points, and tested at sea. In 2023, aboard JS Osumi, Japan fired a ship-mounted railgun at a real target, not a lab demo. The results shocked experts. Mach 6.5 muzzle velocity, over 120 consecutive shots without catastrophic barrel failure, slugs weighing approximately 0.7 pounds, traveling at more than 2,200 meters per second. Japan's approach was pragmatic. Smaller slugs, modular capacitors in ISO containers for power storage, and simplified slug designs for mass production. Where the U.S. failed on endurance and engineering for sea conditions, Japan engineered reliability. This wasn't a prototype stunt. It was operational testing that proved railguns could be practical, survivable shipboard weapons. Tokyo then accelerated partnerships with France, Germany, and invited U.S. contractors back into the fold. The message: railguns moved from theory to deterrent. Numbers matter. A Chinese DF-17 or DF-26 hypersonic missile can cost tens of millions. Japan's railgun can dispatch a defensive slug for roughly $25,000. That cost exchange flips strategy. A nation can be forced to spend millions per strike, while the defender responds with comparatively pocket money rounds. Logistics change too. Slugs are small, storage is simple, and production scales. The economic pressure on an adversary becomes real. Keep launching expensive missiles or accept losing sea control. Weapons aren't only measured in speed or energy. They're measured by the market that sustains their use. Now, quick, pick a side. If you believe steel at Mach 6.5 will dominate future wars, type railgun in the comments. If you think lasers will rule the skies, type LASER. Let's see which technology the audience backs before history decides. China's answer came publicly and proudly. During a major parade, the PLA revealed the LY-1 high-energy laser turret, a system built to track, lock, and burn targets with high precision. Mounted on robust platforms, the LY-1 is aimed at drones, seekers, and light craft systems where cost per target is low and beam delivery is effectively instant. Lasers are economically brilliant. Electricity is cheap, and as long as power and cooling hold, shots are effectively limitless. Against swarms and cheap unmanned threats, lasers are game-changing. On parade ground demonstrations, the system looks flawless. Instantaneous kills, near-infinite magazines, and no logistical tale of explosive warheads. Lasers excel where economics and precision matter. They can neutralize hundreds of drones for a fraction of the cost of interceptors. They offer instantaneous engagement with no travel time, and their targeting can be surgically precise, disabling sensors or melting structural components without collateral explosions. For literal defense, convoy protection, and anti-swarm roles, lasers reduce the kill-cost ratio to near zero. In constrained scenarios, clear weather, stable platform, reliable cooling, lasers deliver unbeatable results. But lasers have brutal environmental vulnerabilities. Fog, rain, humidity, salt spray, and atmospheric turbulence scatter and absorb beams, starving them of effective energy. To burn through a supersonic missile, you must maintain beam lock for seconds, a near impossible task in choppy ocean air. Optics corrode at sea, cooling requirements are severe, and real combat brings smoke, debris, and spray that degrade performance. Even America's Helios trials showed naval lasers struggle with consistency. In short, lasers are brilliant in controlled conditions and fragile in real marine battlefields. In a real naval battle, which weapon actually wins? Imagine two warships on the open sea. One fires a swarm of cheap drones to overwhelm defenses. Here, the laser dominates. It doesn't need missiles or ammo. It just fires beam after beam, burning each drone out of the sky for almost no cost. A railgun could shoot them too. But why spend $25,000 per shot when a laser does it for pennies? But switch the scenario. Now imagine China launches hypersonic missiles, each one flying at over Mach 5, twisting and turning as it approaches. A laser tries to lock on, but rain, fog, or even sea mist can block the beam. It needs 3 to 5 seconds of perfect focus to burn through. In real combat, nearly impossible. This is where the railgun takes over. It doesn't care about weather. It doesn't need lock time. It just fires a metal slug faster than sound, and anything it hits simply disintegrates. So the truth is clear. Lasers are perfect for cheap threats. Railguns are built to kill the expensive ones, and the Navy that combines both will control the future seas. The true future is not railgun or laser. It's railgun and laser. Japan proved railguns can work at sea. China proved lasers can be devastating when conditions allow. The US once led both fields and may soon rejoin. When the first real conflict tests these systems, it won't be aircraft alone that decide victory. It will be a mix of slugs at Mach 6.5 and beams of light. Want the next deep dive? Comment DDX, and I'll break down Japan's DDX destroyer plans and how dual railguns could change naval strategy.